Imagine that we could travel back in time. Not 1,000 years, not 1,000,000 years, but about 4.6 billion years ago. At that time, there was no Earth, no Moon, no Mars, and no Jupiter. Even the Sun did not exist yet. Our future solar system began as a gigantic cloud of gas and dust inside the Milky Way galaxy. This cloud consisted mainly of hydrogen and helium, but it already contained heavier elements such as iron, carbon, oxygen, and silicon. Where did they come from? From ancient stars. When massive stars die, they explode and scatter material into space, material that can later become new stars, planets, and even living organisms. In other words, everything that makes up Earth was once part of ancient stars. Then, one day, a powerful stellar explosion occurred near this cloud, a supernova. The shock wave passed through the cloud and seemed to give it a push. The cloud began to collapse. The more it collapsed, the faster it started to spin. More and more matter gathered at its center. Pressure increased. Temperature continued to rise. Finally, nuclear fusion began in the very center. This was the birth of the Sun. The Sun became the central object of the entire system. It is so massive that its gravity holds planets, asteroids, comets, and everything else in orbit around it. Today, our solar system contains 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. But the planets did not appear immediately. After the Sun was born, a huge rotating disk of gas, dust, ice, and rocks remained around it. This disk is called a protoplanetary disk. Simply put, it was a gigantic cosmic construction site. Tiny dust particles collided and stuck together. Dust became pebbles. Pebbles became large rocks. Large rocks became the seeds of future planets. Scientists call these objects planetesimals. They collided with one another for millions of years. Some were destroyed, others grew larger and larger. Gradually, planets began to form around the young Sun. Closer to the Sun, temperatures were extremely high. Light gases could not remain there for long. As a result, the inner planets became rocky worlds. This is how Mercury, Venus, Earth, and Mars were formed. They are relatively small, dense, and solid. Mercury ended up closest to the Sun. It is a small, rocky planet with almost no atmosphere. Its days are extremely hot, while its nights are freezing cold. Venus grew to nearly the same size as Earth, but its fate was very different. Its atmosphere became extremely dense and hot. A powerful greenhouse effect developed on Venus, making it the hottest planet in the solar system. Earth, the giants, and the final shape of the solar system. Earth became the third planet from the Sun, and that distance turned out to be extremely fortunate. It was neither too hot nor too cold. Later, this would allow water to remain in liquid form, and liquid water is one of the most important requirements for life. Mars became the fourth rocky planet. Long ago, liquid water may have existed on its surface, but Mars is smaller than Earth, its gravity is weaker, and its magnetic field has nearly disappeared. Over time, it lost most of its atmosphere and became a cold desert world. Farther away from the Sun, temperatures were much lower. Large amounts of gas and ice remained there. As a result, the outer planets became giants. Jupiter is the largest planet in the solar system. It is so massive that its gravity strongly influenced the fate of other planets and countless asteroids. Saturn is famous for its magnificent rings. They are made of ice, dust, and rocky particles. Uranus and Neptune orbit even farther from the Sun. They are cold ice giants. They consist mainly of gases, ice, and dense inner layers. Between Mars and Jupiter lies the asteroid belt. These are the remnants of material that never managed to form a full-sized planet. Jupiter's powerful gravity constantly prevented these objects from coming together. Gradually, the solar system took its final shape. At the center was the Sun. Orbiting around it were 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. But it is important to understand one thing. When the solar system was forming, not all of the material became planets. After this enormous cosmic construction project, a lot of leftover building material remained. These leftovers included rocks, icy chunks, dust, and debris. Some of these fragments became asteroids. Asteroids are small, rocky bodies that also orbit the Sun. You can think of them as pieces of material that could have become a planet, but never did. A particularly large number of asteroids remained between Mars and Jupiter. This region is known as the asteroid belt. Why didn't another planet form there? Because nearby lies the giant Jupiter. Its powerful gravity constantly prevented these rocky objects from peacefully combining into a single large planet. Besides asteroids, the solar system also contains comets. Comets are icy bodies made of frozen water, dust, and gas. They are sometimes called dirty snowballs. Most of the time, comets remain far away from the Sun. But when a comet travels closer, its ice begins to evaporate. That is when it develops a beautiful glowing tail. This tail does not trail behind the comet. Instead, it always points away from the Sun because it is pushed outward by the solar wind. But there were other celestial bodies as well. Some of the remaining fragments became moons of planets. A moon, or natural satellite, is a celestial body that orbits a planet rather than the Sun. For example, Earth has one natural satellite. It is the Moon. But the Moon did not appear as a random rock drifting near Earth. Its story is unique. When Earth was still very young and covered in molten rock, a massive object about the size of Mars collided with it. Scientists called this object Theia. The impact was unimaginably powerful. Part of the material from the young Earth and Theia was blasted into space. These fragments did not travel very far. Instead, they began orbiting Earth. Over time, they collided, merged, and gradually formed a single large body. That body became the Moon. At first, the Moon was much closer to Earth than it is today. It would have appeared enormous in the sky. Over billions of years, the Moon slowly drifted farther away. Yet it still remains our constant companion and continues to influence our planet. The Moon helps stabilize Earth's axial tilt. In simple terms, it helps Earth rotate more steadily through space. The Moon also creates the ocean tides. Many scientists believe that these tides may have played an important role in the development of early life on Earth. And so an entire planetary system formed around the Sun. At its center was the Sun. Orbiting around it were 8 planets. Some planets gained natural satellites. Asteroids remained between the planets. Icy comets survived in the distant outer reaches of the solar system. And among all these worlds was the young Earth, not yet blue, not yet covered by oceans, forests, animals, or people. Yet it was on this world that the conditions for life would slowly emerge. Conditions that did not develop on the neighboring planets. And this leads us to the most important question of all. Why did Earth become the home of life? When the young Earth was first forming, it looked nothing like the beautiful blue planet we know today. It was a glowing ball of molten rock. Its surface was covered with lava. Asteroids constantly rained down from space.
There were far more volcanoes than exist today. Yet, within this chaos, the conditions for future life were slowly taking shape. Earth happened to be at just the right distance from the Sun. This region is often called the habitable zone. But it is important to understand that this is not a magical place where life automatically appears. It is simply a region where liquid water can exist on a planet's surface, not permanently frozen as ice, not permanently turned into vapor, but existing as liquid water. And liquid water is one of the most important requirements for life. Earth was also fortunate in its size. It is large enough to hold on to an atmosphere, but not so massive that it became a gas giant like Jupiter. Its gravity was strong enough to keep air surrounding the planet. Earth also possesses a metallic core. Deep inside the planet are enormous amounts of iron and nickel. The movement of molten material within Earth's interior generated a magnetic field.
It protects the planet from the solar wind. The solar wind is a stream of charged particles coming from the sun. If a planet has weak protection, its atmosphere can gradually escape into space. Something similar happened to Mars. Mars was smaller than Earth. It cooled more quickly. Its magnetic field weakened. Over time, the solar wind stripped away much of its atmosphere. As a result, Mars became cold and dry. Earth, however, managed to keep both its atmosphere and its water. But there was another important factor, the Moon. We have already talked about how it was formed. After the gigantic collision between the young Earth and Theia, an unusual natural satellite appeared beside our planet. For life on Earth, the Moon turned out to be incredibly important. It helps stabilize Earth's axial tilt. Simply put, the Moon prevents Earth from changing its orientation in space too dramatically. Because of this, our planet's climate has remained relatively stable for millions of years. Without the Moon, climate changes could have been far more extreme and unpredictable.
Gradually, Earth began to cool. Water vapor in the atmosphere condensed into clouds. Then the rains began. They lasted for a very long time. Water filled low-lying areas. This is how the first oceans formed. The oceans became a vast protective cradle for future life. Water shielded early life from harsh radiation. It also helped maintain stable temperatures. Within water, different substances could mix and react with one another. That is why life most likely began in the ancient oceans rather than on land. But why not on other planets? Mercury is too close to the Sun. It has almost no atmosphere and experiences extreme temperature swings. Venus is similar to Earth in size, but its atmosphere became far too dense. Surface temperatures are extremely high, and the pressure is crushing. Under such conditions, Earth-like life is almost impossible. Mars may once have been more Earth-like, but it is smaller. It lost much of its atmosphere and became a cold world. Perhaps simple life could have existed there in the distant past, but so far, we have found no reliable evidence. Jupiter, Saturn, Uranus, and Neptune are not solid worlds like Earth. They do not have a familiar surface with oceans, continents, and stable environments. Some of their moons, such as Europa and Enceladus, may hide oceans beneath thick layers of ice. Scientists study these moons as possible places where simple life could theoretically exist. But for now, only one planet is known to host life: Earth. Its uniqueness is not due to a single factor. It is the result of an extraordinary combination: the right distance from the Sun, the right size, a protective atmosphere, a magnetic field, liquid water, the Moon, long periods of stability, and countless coincidences that came together in exactly the right way. That is why Earth became more than just a rocky world in space. It became the home of oceans, clouds, plants, animals, and us.